Hello, so today we're going to look at systems of equations. All right, so we're asked to, let me get rid of this there. We're asked to solve the following system of equations. Pick a color. Okay, so we have two equations and two unknowns. So we haven't seen matrices yet, so we can't do that. So let's see. So we're going to use, I think, substitution or elimination. Why don't we try elimination? So let's label our equations 1 and 2. I'm going to multiply equation 2 by the number 2, and I'm going to get negative 2x plus 4y equals 0. And then I'm going to add equation 1 to it. This is equation 1. I'm going to put the plus sign, add them both together. And what do we get? We get 0x plus 5y equals 0. Looks like y equals 0. Okay. Interesting. All right. We got y equals 0. We're going to take that y value. We're going to plug it into one of our two equations. So y equals 0 in, say, equation 1. And then we get 2x plus 0 equals 0 and x equals 0. So therefore, x, y equals 0, 0. So we've solved our system of linear equations. Not a very exciting solution. Let's try this one. Oh, this one's interesting. We have two equations again, 1 and 2, 3 unknowns. Okay. All right, so again, let's multiply the second equation by 2 and see what we get. We get 2x minus 12y plus 12z equals 16. And we're going to subtract equation 1. Let's just write equation 1 down again. All right. Then we get 0x. We get negative 15y. It's 5z. Okay. Plus 7z. And oh, it's a big number. And we have 16 plus 21, so that's actually 37. It's not real pretty, but at this point we can solve for either y or z in terms of the other variable. So let's solve for y in terms of z. So y equals 37 minus 7z over negative 15. So now that we have that, we can take this y value and plug it into either equation 1 or 2 and solve for x. Actually, why don't we plug it back into 2? That probably looks easier. All right. So then, whoops. Let's go up here. Plug this into 2, and we have x minus 6. Our y is 37 minus 7z over negative 15 plus 6z equals 8. So the goal here is to rewrite two of our variables in terms of the third. And this is exactly what we're doing. So now x equals, we can bring everything over to the other side, 8 minus 6z plus 6 over 37 minus 7z over negative 15. And we can clean this up and see what we get. Common factor of 3 in here, which is nice. We got a negative, so bring that out, negative 2. 37 minus 7z over 5 now. Let's put everything over a common denominator of 5. 40 minus 30z minus 37 times 2. That's a big number. What is that? That's 74, I believe. Let's check. Minus 74 plus 14z all over 5. So x equals negative 36, I believe. Oh, my mistake. That's right. Negative 34. Okay. Minus, I believe that's 16. Let's check. Yeah, my arithmetic's not very good this morning. Okay, 16z all over 5. All right. So solve the following linear system. So in this case, our solution is, therefore our solution is, let's write it this way, x, y, z equals, x is negative 34 minus 16z over 5. Y is 37 minus 7z over negative 15. And z is just z. Z can be any real number. Good, so we have a parameter in our solution. So when we have a parameter, one parameter in our solution, we actually have our line is described as a, sorry, our solution can be represented by a line. In the first exercise, we had a single point, no parameters. So our solution is just a point. So when there are no parameters, our solution is a point. When we have one parameter, so one free variable, we have a line. If we have two free variables or two parameters, our solution is a plane, and so forth. All right, so this brings us to the end of our session. If you have any questions, send us a note at info@raisebymarks.com or give us a call day or evening, and we'll be happy to answer your questions. Thank you for watching, and we'll see you soon.